a Portuguese man of war thing. Anyway. Okay. Cubozoa. Class Cubozoa. These are our box jellies. Box jellies are so cool. In Cubozoa, the Medusa form dominates. Okay, so they're mostly in the Medusa form. And the reason why they're called Cubozoa is because if you take their bell and you cut them, okay, across their bell, take a cross section and you look at it from the looking down at the top of this bell, it has like a box shape. Okay, so Cubozoa, box jellies. All right, so these are all box jellies. So, form of the Medusa of your box jellies. So, their bell is square, okay, and on each of the corners of their bell, they have these things that are called pedalia, okay, where all of their tentacles attach. So if you look at this, I'll scroll back up for your notes. Here's your box jelly bell, and then at each of the four corners, those are the pedalia. Those are like the fleshy areas where your tentacles actually attach. Underneath of the bell, you have this flap of tissue that's there that's called the velarium. Okay, and that velarium is there to actually increase the speed of the box jellies swimming. So what it does is it takes and actually narrows the opening at the bottom of the bell so that when that box jelly contracts and squirts the water out through the bottom of the bell, it increases the pressure and causes the box jelly to actually swim faster. And the box jelly can actually swim faster than an Olympic swimmer. So a box jelly could beat Michael Phelps in a race. The box jelly, the largest one, the Tyrannex fleckeri, the deadly one, will be the bell can reach up to about the size of your head, and the tentacles can be about 10 feet long. So it's booking pretty fast, yes. Because of that velarium underneath narrowing the opening, which creates more pressure. Yep. Yeah.
Anywhere near California?
The big box jellies, no. But you'll see. Maybe.
All right.
You'll see. Watch the movie on Friday and you'll see all about that.
Friday?
Wednesday. Sorry. Double block. Okay. So, pedalia. Okay, where your tentacles attach, in between there, you have what are called the rhodophalium, which are right there. So if this is underneath the box jelly, here's your pedalia, here's the rhodophalium. The rhodophalium are where all of the sensory structures of your box jelly are located. So box jellies actually have 6 eyes on each side of their bell, giving them a total of 24 eyes. These are not simple eyes. Not all of them. So they actually have 2 eyes that are actually quite complex. One, which actually has a lens and a retina and like a pupil. Okay, and you've got a picture of it actually in your notes. So if you look, this is the picture in your notes. I'll go back to those so you can get all the notes. So this is the rhodopalia. Okay, this is its eye. Okay, one of its eyes. So can you see it's kind of got like the pupil, right? And then it's also got a lens and a retina in there. Yeah, and an iris. Okay, these are its other eyes. If you look at it straight on, here you can see all 6 eyes. These are located on each side of the bell, 24 eyes. Yes. So they're light-sensitive spots. The other ones are light-sensitive spots. These ones are actually like more complex eyes, this big one and then the other big one right there. But we don't really know how they process that information, right? They have no brains.
So doesn't that mean that whatever they take in is upside down as well?
Probably, yeah. So it's strange. Maybe not because no, it probably is. So, and what's weird, guys? Even weirder, yes, is these rhodopalium are attached to a stalk, and so they can actually rotate these. And so the box jelly can actually like look through its stomach because it's clear, and so it's got a 360-degree view all the way around of what is around it. Yeah. So it can swim fast, it can see, and it's like the most venomous creature in the world. Comforting, right? Okay, so it can look all the way around. Underneath the eyes on the rotopalium are these things called statocysts. Okay, and statocysts, on the inside of them, they have these things called statoliths, which are these kind of like little rock things made out of calcium sulfate. And that actually helps the box jelly to detect orientation, meaning which way is it facing, up, down, sideways. Okay, the statocyst will tell it. And if you look at those statoliths, they actually have daily growth rings on them, so you can tell how old the box jelly is by looking at them. All right. So that's what that is. So in this picture, see underneath the eye how like you've got, it looks like a bunch of these like little rocks. Can you kind of see that? Okay, right here. Okay, this is the statocyst, and then these kind of like rock things inside here, those are the statoliths. Okay, and so as the jellyfish moves, these actually hit little hair cells in there, which will tell the jellyfish which way it is facing. Okay, and then here's what it would look like, the whole rotopalium on the box jelly itself. So, go. Okay, stinging cells. So the box jelly stinging cells, they do have nematocysts. They do produce toxins, and it is deadly. So their nematocysts are actually concentrated in rings on the tentacles. So if you were to look at the tentacles, there are like, it has stripes, okay, and the stripes are where the nematocysts are concentrated. And they do that for a reason. When those box jellies sting, okay, the tentacle actually contracts, which squeezes more venom into the prey. So it actually takes, not only does it just like inject, like, you know, sting you, but then it contracts and pushes even more venom into the prey. In like the big box jelly, like Tyrannex fleckeri, the nematocysts are actually not on the bell, so they're only located in the tentacles. So here's what a tentacle would look like. Okay, so here's where like the nematocysts would be located. Can contract and squeeze. And then here's an unfired nematocyst under the microscope. All right. Okay. So the valerium is that flap of tissue underneath that narrows the opening and allows for the box jelly to swim much faster. Okay, and we think that's at least partly responsible for the reason why they can swim so fast. Okay. This picture that I'm about to show you is actually the underside of a box jelly. So if you're looking like up at the box jelly and the tentacles are moved to the side, this is what you would see. Okay. So this is the underneath. Here's like the pedialia, okay, and then the rotophalia, okay, on each side. And then see this flap of tissue right here? Okay, that's the valerium. It does look like a face. Yeah, the eyes and like the nose and the mouth. But it's actually the underside of the box jelly. So, and then this is that flap of tissue, the valerium, that narrows the opening and allows for it to swim fast.
Eyes like here and then here as well?
Yeah, on each of the four corners, so, or four sides. Right. So if these are where the tentacles are, then it's got eyes here, 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 and here. Right. And so you're looking at it kind of like this way. Right. Okay? No, they can't sink through wet. Yeah. This is the mouth of the box jelly. Okay, so if you're a prey item, this would be probably one of the last things that you see. Going through the mouth of the box jelly. Okay, box jellies actually are ecologically important. So They keep their prey populations under control, so they eat fish. They're actually active predators of fish swimming around hunting prey. And so they're active predators of fish. They eat things also like worms and certain kinds of crustaceans. We swim around eating them. And it's kind of hard to see in this picture because they are see-through, but you can kind of see the tentacles. This is like a swarm of box jellies. You see, yeah. So see like the lines. Those are the box jellies. Yeah, no thanks. Okay, how they reproduce is interesting. So they actually pair up to reproduce, and the male will pass a packet of sperm to the female. The female will take it into her gastrovascular cavity, where she will fertilize the eggs. Okay, and then depending on the type of the box jelly, the species of the box jelly, either the fertilized egg will be released into the water, where it will then become a larva. Okay, and that larva will swim around. Or that fertilized egg will develop into a larva inside of the gastrovascular cavity, and then it will be released into the water. Either way, larva in the water for a few days, and then that larva will settle down onto the seafloor. It could kind of be considered live birth a little bit. It'll settle down onto the seafloor. That little polyp can actually bounce around, guys. Can bounce around, jump around on the seafloor, and as it does that, it can actually like make new little polyps. So when it bounces to the next spot, it'll leave a piece behind, and that can grow into a new polyp. So it bounces around, creating new polyps, and then that polyp will actually metamorphosize and become the box jelly, Medusa. Okay, so it actually changes form and swims away and is the Medusa. All right. And there's your picture of a box jelly. So, Carukia barnesi. This is one of the types of box jellies. It's a little teeny tiny box jelly, and it causes this thing that was known as Irukandji syndrome. And so it's found in the northern parts of Australia near Cairns by the Great Barrier Reef. And so it's called Irukandji syndrome because there is an Aboriginal tribe, the Irukandji, who lived in Australia in that area. And people would go into the water and then come out and have these symptoms of excessive sweating, muscle cramps, a horrible headache, and intense pain for a few days. So it's called Irukandji syndrome. They didn't know what was causing it. And then the guy who found it, Dr. Barnesi, ironically enough, named after him. He thought it was caused by a jellyfish, so he found this little box jelly, and in order to prove his point that it was actually this jellyfish that was causing Irukandji syndrome, he stung himself with it, he stung his son with it, and he stung the lifeguard on duty with it, and then they all came down with Irukandji syndrome, and that was his proof that that box jelly, on purpose. Okay. Right? Thanks, Dad. That's what it looks like. It's small. Okay. When you first get stung, so it's just kind of like a little pinprick, and then about 20 to 30 minutes later, that's when it starts really setting in. And it is lethal. We do know of at least one person who's died from it, but it's typically not. Yeah, those would be where its eyes would be located. Okay, this one I can't pronounce. So this one is found in Guam. Okay. It's small, so a big, fully grown one would only be 1 centimeter. So it's teeny tiny. It spends most of its days attached underneath rocks with sticky pads on top of its bell. And it's not deadly, but it does deliver a very painful sting. And if you are snorkeling at night around Guam, with a flashlight or scuba diving, they're actually attracted to light, so they can come and get you. So that's what they look like. Yeah, but not as fast as this guy. So this is the deadly one. Okay, it's not that great of a picture of it, but Tyrnex fleckeri, the deadly one. So it'll be the size of a human's head, have tentacles 10 feet long. If you get stung with about 5 or 6 feet of a tentacle, you will die in about 2 to 3 minutes. Okay, so it is intense. What? You can hold it because it doesn't have stinging cells on the bell. All of its tentacles will have all of the stinging cells on it. So you can pick it up and, like, as long as you don't touch the tentacle, fine. So you'll see a lot about this one on the movie. Okay, guys, hold on. Last type, this guy looks like the Tyrannex fleckeri, but he's actually not deadly. So it looks like it just will deliver a very, very painful sting as well. Okay, and here's where I got all my information about cubozoans.